we're going to start with our parent function for a parabola, or the squaring function. So our parent function for a parabola looks something like this. And that's going to be our f of x equals x squared. Or I'm just going to do y equals x squared, and that's our parent function. So if we make a few observations, we look at a parabola like this, and the first thing that we're going to note is that this graph has y-axis symmetry. So we're going to note that our graph has an axis of symmetry. This axis of symmetry goes through the lowest point on our parabola, which is called the vertex. And in this case, our vertex is located at the point 0, 0. So if I were to create another function, g of x, by taking our function y and doing composition with x minus 3, that would give me, replacing x with x minus 3 would give me x minus 3 squared. Well, thinking back to what we did in chapter 2, that would take our graph and it would shift the entire thing 3 units to the right. So we imagine we take this picture, and it's going to take our vertex and move it 3 units to the right. And everything else for that matter. So we get something, and it would look like this. And in our new graph, we would have our vertex would now be located at 3, 0, but we would also notice something else. Our graph no longer has y-axis symmetry, but it is still symmetric through its vertex. So it still has an axis of symmetry. And if we think way back to chapter 1, it's been a long time, the equation for a vertical line, remember x doesn't change on a vertical line, so it's going to be x equals whatever our x value was, which is 3. So that's going to be our axis of symmetry in this case. We're going to do one more example. If I create a new function h of x by taking g of x and adding another number to it, say 4, well then that would be g of x, which is x minus 3 squared plus 4. And adding 4 to something on the outside, what would that do to our graph? It would shift it up 4 units. So that would take our parabola once again, so over 3 right and up 4, it's going to take our vertex and move it up here to the point 3, 4. And in fact, it moves all of our other points up as well, and we end up with something that looks like this. We'll notice that our graph still has an axis of symmetry. And it's still x equals 3, because moving the graph up and down only changes the y, not the x. So our axis of symmetry would be in the same place. So the only translation that we haven't done is stretching and shrinking, and we'll talk a little bit about those later. But combining all of this together shows us a couple of things. Our parent function contains the origin at its vertex. So the vertex always goes through the point 0, 0. If we shift our function to the right or the left, it changes the x-coordinate of the vertex. If we shift our function up or down, it changes the y-coordinate of the vertex. This gives us what is called the vertex form of the parabola. So if we write it as f of x equals a times x minus h squared plus k, this is our vertex form. The vertex is located at the point h comma k, because it shifts it right h units and up k units, just like what we saw up here. So it's going to move our vertex to the point, just like here it moved it right 3 and up 4, our vertex was at the point 3 comma 4. So in general, when we have vertex form like this, our vertex is always located at the point h comma k. 2, the axis of symmetry is the vertical line x equals to h. 3, the a value tells us the following. If a is bigger than 0, our parabola is going to be happy and it's going to open up. If a is less than 0, our parabola is going to be sad and it's going to open down. If it opens up or it opens down, we'll notice that our parabola then, if a is positive, it opens up. At its vertex, we're going to have a minimum. If our parabola opens down, it's going to have a maximum at the vertex. So in our vertex form, h and k tell us where the vertex is, h tells us where the axis of symmetry is, and then a tells us whether our parabola opens up and is happy, or if it opens down and it is sad. The a value also tells us then if we have a maximum value or a minimum value. And the maximum or minimum is always located at the vertex. So, as we can see, it seems like the vertex is a very, very important point. So, we have our vertex form, but in the previous section we were working with most of our quadratics in standard form. So then that raises the question, how do I find the vertex of f of x equals a x squared plus bx plus c? Well, that is a good question. As always, we can answer most good questions with a wonderful picture. So let's draw a picture and see if we can figure this out. So I'm going to draw a parabola, and the point we are trying to find is the vertex, which we have named h comma k. We know from our diagrams that we drew up here that the vertex contains a vertical line that is the axis of symmetry. Well, if our parabola is symmetric through its vertex, what would that tell me about these two distances? What would they have to be? Well, since our graph is symmetric, if we fold it over the symmetry line, it would have to land on top of itself. So these two distances would have to be the same. Well, then that tells us that H is at the midpoint of the zeros of f of x equals ax squared plus bx plus c. So by symmetry, since we knew these two things were the same, if we knew the x-intercepts, or the zeros of f of x, we know that h would be at the midpoint. If we knew what those were, we could figure it out. Well, it turns out we do. We just came up with a formula that tells us in terms of a, b, and c what these 2 points are. So the larger one is going to be x equals negative b plus the square root of b squared minus 4ac all over 2a. And the smaller one over here is going to be x equals the negative of b minus the square root of b squared minus 4ac all over 2a, right? Because the quadratic formula gives us both x-intercepts or both solutions or both zeros, one with the positive sign and one with the negative sign. So how do we find the number that is halfway in between two other numbers? Well, we find the midpoint by finding the average. So this number h that we're looking for is at the average of these two things. So h is equal to negative b minus the square root of b squared minus 4ac all over 2a plus negative b plus the square root of b squared minus 4ac all over 2a, and then all of that divided by 2. And you're like, wow, that's a mess. But it turns out we already have a common denominator of 2a in the top, and I have a negative square root of b squared minus 4ac and a positive one. So they add up to 0 and cancel out. So then this gets a lot nicer. I have negative b plus negative b over my common denominator of 2a all divided by 2, which I can make into a fraction. So negative b and negative b is negative 2b over 2a, and then if I have a fraction divided by a fraction, I multiply by the reciprocal. So we do this. Our 2's in this first one reduce out, and we get negative b all over 2a. This is what is referred to as the vertex formula, or at least part of it. So to find the vertex of f of x equals ax squared plus bx plus c, we use h is equal to negative b divided by 2a, and k, well, to find the same k value, if I know the input, the k is the output when I put h into f. So then k is equal to f evaluated at h. All right, so the vertex formula is really, really nice, and we were able to come up with the vertex formula because of the symmetry in this graph. Symmetry is great because symmetry gives us free information. All right, now armed with these formulas, we are finally ready to go ahead and take a look at our first example. All right, example 1 says, for f of x equals x squared minus 2x minus 12, we're asked to do 4 things. A, find the vertex. B, find the axis of symmetry. C, determine whether there is a maximum or minimum value and find that value. And D, graph the function. Okay, so we need to do all of these things. So to find the vertex, for part A, we need to use our vertex formula. So we identify our A, our B, and our C. So our A is 1, our B is negative 2, and our C is negative 12. And that's actually a typo. Let's go ahead and change that. That shouldn't be negative 12. It should be negative 2. So it should look like this. So our C should be the value of negative 2. All right, so then we want to use our vertex formula. So H is equal to negative B over 2A, so that's negative negative 2 all over 2 times 1. So that's positive 2 over 2, which equals 1. So that gives us our H. To find our corresponding K value, we do f of H. So in this case, that's f of 1. So that's going to give us 1 squared minus 2 times 1 minus 2. So 1 minus 2 gives us negative 3. So the vertex is located at the point h comma k, which in this case is 1 and negative 3. So now the next thing we need to find for part B is our axis of symmetry. Is x equals to h, and we found that our h value was 1. And then C, we want to determine whether or not we have a maximum or a minimum. So our a value was equal to 1, and we come back here. Our a value is 1, so it's bigger than 0. So that means our parabola is happy, so it's going to look like a smiley face. It's going to open up. That means it's going to have a minimum value at its vertex. So since a equals 1, we know our parabola is going to be happy, and it opens up, so we're going to have a min, and the minimum is at our vertex at 1 and negative 3. So then lastly, part D says we want to graph our function. So we go to our vertex, which we found, which is 1 and negative 3. And then our a value, we know that it opens up, but the a value acts in a way that allows us to find 2 other points on our parabola. So we know it's symmetric because this is our axis of symmetry, runs through the vertex. And what we do is we're going to go 1 unit to the right and 1 unit to the left, and then we're going to go a unit. So I go 1 unit to the right and 1 unit up, 1 unit to the left and 1 unit up, and that gives me my 3 points with which to make a parabola. All right, so for utri number 1, first thing we need to do is find our vertex. So our h is going to be at negative b over 2a, so negative negative 6 over 2 times...
Not sharing your screen, Professor.
So we'll try that again. So for A, we have our h is negative b over 2a. So that's going to be a negative 6 over 2 times 1. So 6 divided by 2 gives us 3. To find our k value, we put our 3 in for x, and that gives us f of 3 is going to be 3 squared minus 6 times 3 plus 3. So that's 9 minus 18 plus 3, and we will get, simplifying, negative 6. So our vertex is located at the point h comma k, which is going to be 3 and negative 6. So then B wants us to find the axis of symmetry, which is x equals h. And we just found h in the previous part, so it's x equals to 3. And then for part C, our a value once again is 1. So it's bigger than 0, so that means our parabola once again is happy. So we're going to have a min at the vertex, which is at 3 and negative 6. And lastly, D, we want to draw our graph. So we go to our vertex, which is 3, negative 6, and then we do our a value using our axis of symmetry. So I go right 1 and up 1, and I go left 1 and up 1 because my a value is 1, and then I connect my 3 things to make a very happy parabola. All right. So our next part is going to expand a little bit on what we were just doing. So this time, the major difference that we note is in this example, instead of being given in standard form, our f of x is given in vertex form. So if we write that down, we have f of x is equal to negative 3 times x minus 4 squared plus 6. And if I compare that with my vertex form, I have a times x minus h squared plus k. I can identify my a, h, and k. So my a is going to be negative 3. And then here we have to be careful, similar to what happened with the equation of a circle, I have a minus sign in my formula. So I have negative h is the same as negative 4. So I divide by negative 1, divide by negative 1, and that gives me h is positive 4. And then lastly, I have a positive k is equal to 6. So my k is just 6. So now I have my a, h, and k. I can use this to graph, because I know my vertex is located at h comma k, and in this case that is 4 comma 6. So I go to my vertex at 4 comma 6, and I know that my axis of symmetry has to go through my vertex. So I'm going to go 1 unit to the right, but now I'm going to use my a value. So I go 1 to the right, but what's my a? Negative 3. So instead of doing 1 like we did in the previous 2 examples, because a was 1, I'm going to go down 1, 2, 3 units. That is my a value that I had right here. And then I do the same thing over here. 1 unit left, and I go down a units. And that gives me the 3 points that I need to make my parabola. So the a is the key to giving me the 2 other points that I need. So I go to the right and the left a units, and I go up and down a units after going right and left 1 to give me the 3 points I need to make my parabola. So in terms of what we talked about in chapter 2, the negative 3 reflected our graph. Instead of opening up, it now opens down. And instead of going 1 unit, it stretched it by a factor of 3, so it went down 3 units. All right, so for example number 3, given f of x, we want to find the vertex, the max or the min, the range, and the intervals of increasing and decreasing. So we need to find the vertex. So we identify A, B, and C. Our A is negative 2, our B is 16, and our C is negative 54. So then h is negative b divided by 2a. So that's a negative 16 over 2 times negative 2, which is negative 16 over negative 4, which is 4. And then our k value is f of h, so f of 4. So negative 2 times 4 squared plus 16 times 4 minus 54. So 4 squared is 16. 16 times negative 2 is negative 32. 16 times 4 is positive 64 minus 54. So simplifying all of that together, we get negative 22. So this gives us our vertex is located at h comma k, which we just found. So our h is 4 and our k is negative 22. Since our a value is negative 2, means our parabola is going to be sad, so it's going to open down. So it's going to have a max at its vertex. So the max is at x equals 4 and y equals negative 22. So then the next two parts, we want to know the range and the intervals of increasing and decreasing. To help me visualize this, I'm going to just do a quick sketch of what my graph looks like. And it doesn't have to be super accurate. So here's 4. Down here at negative 22, I have my max value, so I know my parabola opens down. And that was at 4, negative 22. So we want to find the range. Well, our range is from the smallest y to the largest y. So it goes from negative infinity, and our largest y is right here at negative 22 included. And then the last part is we want to know where the intervals of where it's increasing and decreasing. Well, we know a graph can change from increasing to decreasing at a maximum. So it's increasing until it reaches its vertex, and then it's decreasing afterwards. So in terms of our graph here, we're going to have that it's increasing from negative infinity to the x value of 4, and then it's going to decrease after the vertex from 4 to positive infinity. So we'll notice in the range, we used the k value, and in increasing and decreasing, we used the x coordinates or the h value. All right. So let's look at try number 3. So before I turn you loose to work on this yourself, you might be thinking, well, this doesn't seem like the same type of thing we just did, and it turns out they're exactly the same thing. So it says a baseball is hit 2 feet above the ground with an initial upward velocity of 48 feet per second. The height of the baseball is given by this equation, where the height s of t is in feet and the time t is in seconds. So we're asked, at what time does the ball reach its maximum height? And B, what is the maximum height of the ball? And C, when does the ball hit the ground for the first time? Well, if I draw just a little sketch to help me see what's going on, we have our input is time and our output is height. And we have a parabola that looks something like this. And we're asked, at what time does the ball reach its maximum height? Well, this is a parabola, so we know that its maximum is going to occur at the vertex. At what time does it reach the maximum height? So that's going to be our input at the vertex. Well, the input at the vertex is h, and what is the maximum height is going to be the output at the vertex. So that's going to be our k. And when does the ball hit the ground for the first time? Well, that's here. That's going to be our 0, or x-intercept. So we need to solve s of t is equal to 0. So to find our vertex for part A, h is equal to negative b over 2a, which is going to be negative 48 over 2 times negative 16. So that's negative 48 over negative 32, which reduces to 3/2 or 1.5 seconds. So the ball is going to reach its maximum height after 1.5 seconds. Then the next part, we're going to put our 3 over 2 into our function, so negative 16 times 3 over 2 squared plus 48 times 3 over 2 plus 2. And this gives us negative 16 times 3 over 2 squared plus 48 times 3 over 2 plus 2. And we get 38. So it will reach its maximum height after 1.5 seconds, and the maximum height will be 38 feet. So then we want to know, well, when does the ball hit the ground for the first time? Well, looking back at our picture, we know that parabolas are symmetric about their vertex. So to go from here to here, we know it took 1.5 seconds. So for the ball to get back to a height of 2 feet, it's going to be double that, so that's going to be the point 3, 2. So based on this, it won't be at the ground at 3 seconds, but it should be about 3 seconds. To find the answer exactly, we use the quadratic formula. So we identify our A, our B, and our C. So our A is negative 16, our B is 48, and our C is 2. So we get T is equal to negative B, so negative 48 plus or minus the square root of b squared, so 48 squared minus 4 times negative 16 times 2 all over 2 times negative 16. So that's going to give us negative 48 plus or minus, and we simplify 48 squared minus 4 times negative 16 times 2, 2,432. All divided by negative 32. So now we need to calculate each of these. So alpha y equals, we get negative 48 plus the square root of 2432, all divided by negative 32. And that gives us one answer. And then we get the same thing, but instead of plus this time, we have the or minus. So we change that to a negative, and we press enter. And we get these two solutions. So we see that the solution we are looking for is this. So t is 3.0411 ... So our approximation was pretty close, about 3 seconds, by using symmetry, but the exact answer is 3.04, or a decimal approximation of the exact answer is approximately this.